One of the most important techniques in the chemistry laboratory is titration. Titration is an experiment in which one solution is slowly added to another solution until a reaction has gotten to the point where both reactants are used up. In other words, there is no limiting reagent. There's some specialized equipment used in a titration that I want to show you. This is a burette. You'll notice it's long, it's thin, and you can't really see it here, but I'll show you a close-up in a second. It is graduated. So there's volume markings on it. And this down here is a stopcock. Stopcock is up and down, like it's shown here in the picture. That means it's open. The liquid can freely drain from the burette. And of course, usually you would have some sort of container here, a beaker or usually an Erlenmeyer flask. When you turn the stopcock parallel to the lab bench, that's closed. Now, the thing about a burette is that 0 is at the top of the burette, and 50 is down here at the bottom of the burette. So when you put a liquid, a solution, into the burette, put it in until it's almost at the top. You don't have to line it up to be 0 at all. Just somewhere close to the top, underneath the graduations. You can't have it up here. You want to know how much liquid is in there. Take a look, though, at the graduations on a burette. Look how precise they are. That's 0 milliliters, that's 1 milliliters, that's 2 milliliters. There's a marking every 1/10 of a milliliter, which means you can estimate to the 100th of the milliliter every time you read a reading from a burette, right down to the 100th of a milliliter. You have a great deal of significant figures here. Use all of them. That precision is usually necessary when you are using a burette. That's why you use a burette. So you fill it up and you read how much liquid you have in the burette. You don't have to subtract it from 50 or anything else. You just read this. This is somewhere, it's hard to tell from the picture, but from the picture I'm going to guess 0.61 maybe. It would be easier in real life. But notice I read that to the 100th. So then you have another solution. You have another solution in your beaker or Erlenmeyer flask or something down here, and you open up the stopcock and you let the liquid drain out slowly. Usually you have some idea of where it's going to end, so you do it quickly until you get there, and then you do it slowly as it gets close. And then there's some kind of indicator here in the beaker, some way to tell when the reaction is done. Oftentimes it's something that changes color when the pH changes. We'll get there. But for suffice to say, something here will tell you the reaction has gone to completion. When you do that, you stop this stopcock. Remember, it's important to go very slowly as you get close to that endpoint, or you'll overshoot it, and you don't want to do that. At that point, what happens is that you have used up some of the liquid in the burette. So now you read this. You say, oh, that looks to me like 29.00 milliliters. Again, I've gone to the 100th. That's your final volume. So the final volume minus the initial volume, that 0.60 or 61 or whatever we had at the beginning, subtracting those two numbers will give you how many milliliters you let out of the burette, and that's how you tell what you did. Then the problem just devolves into stoich. Remember your molarity rules and your stoichiometry rules, and you'll be just fine with the math of a titration.